Hello there. I wanted to talk a little bit about special factorizations. Sometimes we have certain forms on our expressions where we have x squared minus y squared or x squared minus x cubed, and it looks like we can't factor anything out because we don't have common factors, so we don't have a greatest common factor, and we can't group. But those expressions can be factored with special factorization rules. So if you look at the a squared minus b squared here, that would be something like, let's say, an x squared minus a 9, or something like a 16y squared minus a 25. All right. I can factor that into an a plus b times an a minus b. So if I look at what a would be here, it would be x squared. So a is x, and my b here is a 3. And so I can factor this into an x plus a 3 times an x minus a 3. Similarly, on this one, my a would be a 4y all squared. And my b is just the 5, which is also squared. So then I can factor it as a 4y plus a 5 times a 4y minus a 5. So if we do a couple of these here, one real quick note, if you'll notice here, this is a plus or a minus sign in the middle. If I have like an x squared plus a 25, that's prime. I can't factor that. So that goes for any a squared plus a b squared. That's not factorable. If I look down here at my x squared minus 81, then I'm looking at an x squared minus a 9 squared. So I get an x plus a 9 times an x minus a 9. If you want to pause and try b, you can. What we have here is a 5t squared minus a 4 squared. So that's going to give me a 5t plus a 4 times a 5t minus a 4. Nice to be able to do that amount of work, right? If I look at this next one down here, okay, well, this looks different. I've got A's and B's. I've got a 12 and a 48. So let's look at what I can factor out. First of all, I can factor a 12 out of both of those. So I've got a 12 times a to the 6th minus a 4b to the 4th. Well, now it looks like I might have something that's squared. Let's rewrite it again. I get 12 times, and I'm going to write it as an a cubed squared. That's going to be my capital A, minus a 2b squared squared. That'll give me a 4b to the 4th if I multiply that out. So now I'm going to be able to write this as a 12 times an a cubed minus or plus a 12b. It doesn't matter which one comes first. And an a cubed minus a 12b. All right. Very nifty. The next one. Wow, it looks a little different, right? I can see that my first two terms here, they look like they both have higher order things, cubes, and these two I can both see are divisible by 9. So I'm going to try a grouping thing. I'm going to pull an x squared out of the first two terms. I'm going to say x squared times an x plus a 3 is what's left in those first two terms. So this goes to that. And then off of these, I'm going to have minus, I'm going to take out a negative 9, so I'll turn those both positive, times an x plus a 3. And now we can see that we have this lovely common factor here in the x plus 3. So let's factor that out. I'm going to have an x plus a 3 times an x squared minus a 9. And that's my answer there. We did not use a perfect or a difference of squares right there. All right, we didn't have a perfect square. Oh, wait, we do now, though. So if I look at this last term right here, oh, see, it almost did from you. I have an x squared minus a 9, and that is a perfect square, so I get an x plus a 3. If you look, my a is an x, so I've got x plus a 3 times x minus a 3. Now we're done. All right, the next one, if you want to try that one yourself, you can. The key to this one is that we notice there's a plus sign right there in the middle, so we can't factor this. This one's prime. That was easy, right? What about the next one? Can we factor that? Well, I can a little bit. It looks like I can take out a 4 from both terms. So I'm going to take out a 4, and I'm going to have an x to the 4th plus a 4y to the 8th. And while I can change both of those into squares, what do you notice in the middle? This plus sign. So right now that part's prime, but I've factored it, so I actually have an answer there. That's just as far as we can go, so this is going to be my answer. All right. So that is right there, the difference of squares and a couple of variations on it. The next one we have is perfect square trinomials. Here, what we see is if we have an a squared plus a 2ab plus a b squared, it's equal to an a plus b squared. And if I have the exact same thing, except for I have this minus sign here instead of the plus, an a squared minus a 2ab plus a b squared, I get an a minus b all squared. So here, what I'm looking at really is I have an x squared plus 2 times 4x plus a 4 squared. And you can kind of see that whole, my a is x, my b is 4, and I've got 2 times 4 and x there. So I can actually change this real easily to a x plus 4 squared. If I look at my next one, b, if you want to try it yourself, go for it. Notice the minus signs there in the middle. So consider that. I'm looking for maybe a perfect trinomial that's the a minus b squared. So let's write this out. So I have an 8x all squared minus 2 times a 64xy plus, all right, that's not right. Let's try a 56. Didn't do that math right. A 56xy plus a 7y squared. So if I look at my a there is 8x, my b is 7y. That means that a times b is equal to 56xy. So indeed, we do have a nice perfect square there with the difference, and so I can write this as an 8x minus a 7y all squared. Okay? Pretty neat how we can do that. So that's us factoring those perfect square trinomials. If I want to find the product here of this, I can do one of two things. I can do 2y minus 3 times 2y minus 3. I can FOIL it. I'm going to get a 4y squared minus a 6y minus a 6y plus a 9, which is going to be equal to a 4y squared minus a 12y plus a 9. So this is one way to do it. The alternative is I can say that a is equal to 2y and b is equal to 3. And so what I'm going to get there is, again, remember that a minus b squared is equal to a squared minus 2ab plus b squared. So I can just write it out. If you memorize the rule, that's fine. I prefer FOIL, to be honest. So I have a 4y squared, that's my a squared, minus 2 times a 6y, that's going to be my 12y over there, and then plus 3 squared, which is 9. So I'm going to get a 4y squared minus a 12y plus a 9. I get the same answer either way. All right. Really quick, note the difference. Here, this x squared minus 4, that one turns into, that's a nice perfect square, an x plus a 4 and an x minus a 4. All right, that's because I have an x squared minus a 2 squared. If I look at this x minus 4 squared, I'm multiplying x minus 4 times x minus 4. So I'm going to get an x squared minus an 8x plus a 16 there. I kind of use this rule that we had for the difference there, and did it in my head. I kind of FOIL it at the same time. This, though, with that plus sign right there in the middle, I get an x squared plus 4. This one's prime. All right. And meanwhile, right next to it, I have an x plus a 4 times an x plus a 4 is what that x plus 4 squared is. That gives me an x squared plus an 8x plus a 16. So you can see a nice relationship between these two. Really, the only difference that's caused by these plus and minus signs is the plus or minus sign inside of there next to that 8x term. All right. One more thing, sum and difference of perfect or of cubes. If I have an a cubed plus a b cubed or an a cubed minus a b cubed, what we see is for a cubed plus a b cubed, we get an a plus a b. Notice this matches this. And then times an a squared minus, notice that's the opposite, ab plus a b squared. The rule for the other one is the same. The first term, the a cubed minus b cubed equals a minus b, and then times an a squared plus, this time, an ab plus a b squared. So if I want to factor this x cubed minus 8, then I have an a plus a b. So this is my a right here, and this is my b if you're looking at, well, my b is actually, hold on, let's rewrite. Okay, this is equal to an x cubed minus a 2 cubed. So what I have is that's equal to, I'm going to match the signs on the first one, an x minus a 2 times an x squared plus the opposite sign there, 2 times x, so a 2x, plus my b squared, which is going to be a 2 squared, so plus 4. If I look at my next one, what I have there is a 3s squared, cubed, it's a little cube, plus a t cubed. This time I'm using the top one up there. Give it a try if you want to. I'm going to get, remember the first one matches, so I get a 3s plus a t, the signs match. Now I do a 3s squared, so I'm going to get a 9s squared minus, because I'm going to do the opposite sign there, my a times b, so I'm going to get a 3st plus my b squared is a t squared. And that's my answer there. My last one here, I'm looking at that 216, trying to think. I think it's a 6. Let me look. 6 times 6 times 6. Yeah. Okay. So I look at it, and the 125 I recognize. This is a 5. Oh, wait, there's y's in both. Let's pull out a y. So I'm going to say this is equal to y times 125y cubed plus 216y. So now, oh, that y is not in the second term. I factored it out. There you go. Now I can say that's y times a 5y cubed plus a 6 cubed. I can use my rule again, and I'm going to say that's y times, remember it's a plus b because I have a plus sign right there, 5y plus 6 times, and then I have my 5y squared, so a 25y squared. Remember now I switch the signs, so minus my a times my b, so I'm going to get a 30y there because I have 6 times 5y, plus my b squared, so 36. And we're done. So those kind of cover the special factoring situations, and I hope that's helpful. It makes things really easy we probably use the most out of these. I mean, the latter two are helpful. This front one of the difference of squares, where I have a nice, beautiful square there, um, that one's used quite often. So I would say that number one, you really definitely want to know that one. All right. Okay. Have a great day, and I hope you enjoyed the video. Bye.